Welcome to Bio Roadmap. This is the first in a series of videos on how we use graphs in science. In this video, we are going to talk about what a graph is. So what exactly is a graph? In science, you can think of a graph as a diagram that shows the relationship between two or more things. The goal of a graph is to help you visually interpret data. For example, imagine that you were helping to run a clinical trial for a new kind of cancer-treating drug. You get 100 volunteers with that cancer for your clinical trial. You divide them up into 5 groups of 20 people, and you give each of those groups a different dose of your new drug. You then record the progression-free survival of each patient. That means the amount of time in months, in this case, that the patient lives with the disease, but it doesn't progress further. Here is a data table showing your results. Let's try to interpret those results just by looking at the numbers in the table, but without looking at a graph. As you can see, people who received the 0 milligram pill or the placebo version of your cancer treatment lived without additional cancer for 6.3 months on average. For people who took the 5 milligram dose of your new cancer drug, that time period increased to 12.4 months. Pause the video for a second and take a look at the table. What do you think about the relationship between dose of your new cancer drug and survival? You should be able to see that each time the dose is increased, the average survival time of the patients increases. However, it can be a little harder to determine more complicated relationships by just looking at numbers written in a table. Here is the same data shown on a graph. Now it's a little bit more obvious to us that the amount that survival is increasing is getting smaller and smaller each time you increase the dose. A relationship like this would be important to understand if, say, your cancer treatment had negative side effects that also increased as the dose increased. At the higher dosages, it may be hard to decide whether the increase in quantity of life is worth the decrease in quality of life that goes with it. You may need to use a graph like this one to help you make that kind of decision. Scientists use graphs then to show the relationship between different things in a much more visual and easy to understand way. There are many different kinds of graphs that scientists use to report their data. 3 of the most common types are the line graph, the scatter plot, and the bar graph. There are some differences in these graphs and how they are used, but they also have many common components. Let's use the line graph from our cancer clinical trial example to talk about the different parts of a graph. Often when you go to make a graph, the first parts that you draw are the axes. Axes are reference lines that help us determine where to plot our data. If you're only talking about one of these lines, you refer to it as an axis. The word axes is plural. The horizontal line is referred to as the x-axis. That's where we graph our independent variable. The vertical line is referred to as the y-axis, and that's where we graph our dependent variable. Each axis may have a set of numbers called a scale. The scale allows you to interpret what the location of the data points or the size of the bars on your graph mean. Each axis should also have a label that tells you what the axis is representing. The axis label should include the units, and the units are often written in parentheses. Here, for example, our x-axis represents the dose of the drug, while our y-axis represents the survival time in months. We use the scale and the labels together to help us interpret what the data on our graph means. For example, if we pick this data point and look straight down at the x-axis, we will see that this data point represents a dose of 15 milligrams of our cancer drug. If we draw a line straight to the left, we see that this point also represents about 17 months of progression-free survival. You can also see here how we're using this graph to show the relationship between the 2 variables of dose and survival. Every graph should have a title that clearly states what the graph is about. The title often states both the independent variable and the dependent variable. Finally, graphs often feature a caption. Say we were writing a scientific journal article on the results of our clinical trial. That paper may include a number of different figures or images and graphs. If this was the first figure in our paper, we would call it figure 1, and then our caption would also include a couple of sentences that describe what the graph says. The caption often features information that's important for interpreting the graph, but that isn't easy to represent within the graph itself. For example, this caption states that 5 groups of 20 cancer patients were given different doses of the experimental drug daily for 3 weeks, and that patients underwent monthly scans to document tumor progression, and that progression-free survival was measured from the date of the first dose. All of that information helps someone who wasn't part of the study understand what this graph means, but it's also information it would be difficult to show just with the graph alone. To summarize what we just said, a graph is a diagram that shows the relationship between 2 or more things, in this case, the relationship between 2 things. Graphs have axes. The scale and labels on the axes show what those axes represent. Graphs have data that can be represented as points or as bars in the case of a bar graph. The data represents the results of your experiment. A good graph should be easy to read, so it should include a title and a caption that help the reader understand what the graph is about. Many people find graphs intimidating at first, but a good graph should make the data easier to understand, not harder. In the next video, we will go over how to start with a data table and build a graph from that.